The last video, part 1, we evaluated some indefinite integrals by finding the antiderivatives. And this time we're going to just get a little bit of practice in evaluating definite integrals. So again, I'm showing you the table of indefinite integrals. It's good to have this to go back to refer to. So let's try to evaluate this integral. So it's a definite integral. So pause and see if you can do it first, and then I'll display the answer. All right, so here we go. The first thing you want to do, remember there is no product or quotient rule or chain rule that is going to help us evaluate this definite integral as it is. So we need to do a little pre-processing. We're going to multiply those two binomials together, and that will give us that 8x cubed plus 2x minus 12x squared minus 3. And now we can find the antiderivative. So that's the first step. We're going to find the antiderivative, and then we're going to evaluate that antiderivative between the boundaries given, between 0 and 2. And for this, we can use any antiderivative, which means our arbitrary constant, we can simply set it to c. So using the reverse power rule for all of these terms, we get an antiderivative of 8x to the 4th over 4, 12x to the 3rd over 3, plus 2x squared over 2 minus 3x, evaluated from 0 to 2, and then of course we're going to simplify that on that next line, 2x to the 4th minus 4x to the 3rd plus 3x squared minus 3x. And then we're going to evaluate that antiderivative at the upper and the lower bounds, and then we simply subtract the two. So you can see the work there, and when we subtract, we get a minus 2. Now remember, that represents the area under a curve. So what does a minus area mean? Well, it's not really a legitimate area. What that's telling us is that most of that curve lies beneath the x-axis. And it could represent a net change in something. All right, the next one, again, pause and see if you can work this. All right, I'm going to display the answer. So the first thing we want to do is change the form of those two terms a little bit so it's easier to work with. So x over 2, we'll just make that 1/2 x. And 2 over x will make that 2 times x to the minus 1. Now taking the antiderivative of 1/2 x, you're going to get 1/4 x squared. Minus, and remember that x to the minus 1, that's the exception to the reverse power rule. The antiderivative of x to the minus 1 is the natural log of x. So we get minus 2 times the natural log of x. We're going to evaluate that between 1 and 2. So we're going to take the value when the antiderivative is equal to, when x is equal to 2. And we get 1 minus, let me catch up with my arrows here, 1 minus 2 natural log of 2. And if you plug in 1, the lower boundary, you're going to get 1/4. And now if you do the subtraction, 1 minus 2 natural log of 2 minus 1/4, the exact answer is 3/4 minus 2 natural log of 2. So remember, in WebAssign, if there are no rounding instructions, you write the exact answer. If you're given rounding instructions, you would write the approximate answer. So you would plug that all into your calculator and get an approximate answer and round it off to whatever is required. All right, just one more example of a definite integral. Again, pause, work it out. Okay, I'm going to display the answer. The first thing I'm going to show you is that the form looks really weird. You have dr over square root of 1 minus r squared. Notice that's the same of 1 over square root of 1 minus r squared dr. Okay, so now that 1 over square root of 1 minus r squared even if you were to convert that to quantity 1 minus r squared to the negative 1/2, we still couldn't work with it. We don't have a chain rule, we don't have a quotient rule, we don't have a product rule for the antiderivative. So this is your clue. Maybe think about going and looking at the table of antiderivatives and see if that appears somewhere. And when you look, you see, oh, that is the antiderivative of the arc sine or the inverse sine. So the inverse sine of r is indeed, or the derivative of the inverse sine of r, I should say, is 1 over square root of 1 minus r squared. So our antiderivative is inverse sine of r. You're going to evaluate that between 0 and square root of 3 over 2. So you simply do that. You have to plug in. Now remember, you have to remember your trig and what an inverse sine means. Inverse sine of square root of 3 over 2, what you're asking is the sine of what angle is equal to the square root of 3 over 2. So you have to go back to your trig knowledge, realize that's one of those special triangles, and the angle that you're looking for is pi over 3. How do I know it's that angle? Because there's a lot of angles where the sine is square root of 3 over 2. Remember, the sine is periodic. Well, you also have to remember that the domain of the inverse sine is only negative pi over 2 to pi over 2. So you can only find legitimate angles for inverse sine in that interval. So pi over 3 fits the bill. And for the second one, when you plug in 0, you want to know the sine of what is equal to 0. Well, the sine of 0 is equal to 0. And it is in the domain of the inverse sine. So now we simply do our subtraction at the end, and we get our answer of pi over 3.